Okay, so this is a view of the front of the Coca-Cola Space and Science Center in Columbus, Georgia. This is kind of optimized for VR view, so there you go, that's a front, and it's going to transition into some video clips. This video to show what the Columbus State Coca-Cola Space and Science Center is all about. It's right over here over my shoulder. This is down on Front Avenue in Columbus, Georgia. It's part of Columbus State University. So they have a school gathering going on, a field trip of some sorts. A lot of buses here, a lot of kids. So this might get a little loud when we're inside. But so this is where we're at. It's a beautiful area right along the Chattahoochee River in downtown Columbus, Georgia. So I'm going to be heading inside now. And this is the front entrance to the Coca-Cola Space and Science Center. You can see a Space Shuttle main engine nozzle behind me. They have some other displays here. And there's the Omnisphere Theater, where they do, it's kind of like a planetarium, and they do presentations. And that's about it for the front entrance here. All right. I'm a little deeper inside right now, and you can see the front entrance behind me, but also all of these displays that are talking about some of the aspects of the space shuttle. You see a nose cone for SRB right there, the backside of the main engine nozzle, and gift shop behind me as well. And then right over here we have some displays from the Apollo mission, and as you can see, I have my Apollo shirt on. And then inside of that area on the other side is the manned maneuvering unit from the Space Shuttle program missions. A little deeper inside, we have the Space Shuttle Odyssey. It's a mock-up simulator. It has a video in it. I recorded the entire thing before, so I'll have to add that here. About 15-minute long presentation. You can actually hear the rumbling from the simulation inside. It's pretty neat, well done, well produced simulation. And then some more displays here behind me. You can also see the there's an astronaut maneuver unit, and then you can see some of these flight simulator machines here beside me, or behind me. Alright, that's that. A little bit quieter now. I guess the launch is complete and Odyssey is in space, heading to the ISS. Alright. Wing here, and they have a little mock-up of a mission control right here in this room. It's called the Challenger Learning Center. It's pretty neat. And they do some different projects with kids inside there. And I am standing in front of the, it's called the Invisible Universe. And you can see me back here on the screen. It's an electromagnet spectrum. So that's that. And then immediately behind me here, I'll go over there in a moment, is the Mars Rover simulations. Well, that's pretty bright. Let me see if I can change my position here. Here's the White Room from the Space Shuttle missions. Looks like the entrance that was signed by a bunch of the different engineers that worked there. And then here we have a green screen that is used to put you on a weather map. So if I show behind here, up there, there's me on the on the weather map, projected from the green screen. And then here we have a video they showed from this past August's Great American Solar Eclipse. I got a good opportunity to go see that in Tennessee. And then let's see here. And so here's the Mars Rover, little rover simulators. It's got a good little video that goes there. And then let me switch the camera over. Mars rover simulations, and you have your little controls right here, and we're able to play with these. Let's see which one's working. Oh, that's it. Gotta hold the button. So I'm on Rover 3 here. I'm gonna back the rover up over here by this crater. See if we can put him right in front of it. Okay, right behind me here is the Space Shuttle Odyssey simulator, and I'm getting ready to go inside and watch the presentation. It's a really neat simulation of a launch and a mission to the International Space Station, so wish me luck. Heading into the gantry next to the Space Shuttle Odyssey experience. So we're heading in, and then you kind of get to this point where you see a little white room, and then we're going to go inside. The show's already begun, but I've recorded this before, so here we go.
Attention all personnel, this is the entity conducting the launch status check. Verify ready to resume count and go for launch. OTC. OTC is still. TBC. Exit booster go. TBC. BTC is still. LPS. LPS is still. Houston flight. Houston flight.
We are going to go inside and watch a presentation called Astronaut. So this Omnisphere Theater is just like that. It has a big dome that you watch the movies on. It's supposed to be really cool, so can't wait.
Stand anywhere on the Earth, and space is never more than a mere 100 kilometers away. At this distance, you are beyond Earth's atmosphere and are officially an astronaut. 100 kilometers. That's less than some people commute to work each day. And yet just 50 years ago, this distance was out of reach. Decades of research and development into spacecraft has allowed us, for the first time in the history of the human race, to leave our planet and explore what is beyond. Technology has given us the tools to break free of gravity and journey beyond our world. But what about the people involved? What does it take to be part of these incredible journeys? What does it take to become an astronaut? Before anyone can become an astronaut, years of mental and physical training must be completed. The long process of developing the skills needed begins much closer to the ground, in fact, underwater. This is a neutral buoyancy training tank, a very deep swimming pool filled with underwater versions of spacecraft and robots. Neutral buoyancy is a state where an object neither sinks or floats. Using a combination of weights and flotation devices, the astronauts are suspended in a kind of underwater weightlessness. To replicate the conditions of an actual mission, real spacesuits are used. Bulky and cumbersome, these suits provide limited mobility and prevent any tactile contact. Getting used to these restrictions allows astronauts to prepare for the complex tasks required in the harsh conditions and microgravity of space. But to truly simulate weightlessness and experience its effects on the human mind and body, we need to head upwards. This is the KC-135 microgravity training aircraft, or the Vomit Comet, as it's affectionately known. To simulate a near zero gravity environment on Earth, we have to counteract the gravitational forces that keep us on the ground. The Vomit Comet achieves this by climbing to high altitudes and then diving back to Earth in an increasingly steep curve called a parabola. In the midst of this free fall, the aircraft matches the speed at which gravity is trying to force it back down to Earth, and a period of weightlessness is achieved. This is similar to the effect you feel when you drive too quickly over a humpback bridge. Imagine if that brief sensation lasted for 20 seconds instead of 1, and it's not hard to see why the Vomit Comet got its name. A lack of gravity is not the only scenario astronauts have to train for. During a launch into space and re-entry, they are subjected to many times the gravitational forces of those here on Earth. Like a huge centrifuge, the capsule on the end of this arm is gradually accelerated up to speed. The faster the arm rotates, the more forces of gravity, or G-forces, are produced. In a typical launch, an astronaut will experience approximately 3 times the amount of gravity that we are used to on Earth. If you have ever been on a roller coaster at an amusement park, you have probably already experienced close to 3G, but only for the briefest of moments. During a launch, astronauts have to endure these forces for 8 crushing minutes. If the G-forces are raised higher, then greater problems can arise. Exposure for more than a few seconds around 6G can cause vision to blur and narrow, and eventually you black out. With training complete, you are finally ready to launch into the hostile environment of space and perform the tasks of an astronaut. With no air to breathe and temperatures that range from freezing to boiling, astronauts must wear specially designed suits that protect them from these extremes. Underneath these suits is a complex network of pipes which continually pump hot and cold water over the surface of the skin, regulating body temperature. The suit also acts as a mini pressure environment that supplies oxygen and protects against the vacuum of space. Spacesuits can protect astronauts from the external effects of space, but what about the internal effects? Humans have evolved over millions of years to be best suited to conditions here on Earth. In the sudden absence of gravity, the body starts to adapt. An immediate result of this adaptation is a condition similar to seasickness. Inside the inner ear, there are thousands of little hairs and small crystals called otoliths. Their function is to constantly update the brain as to which way is up. But without gravity, there is no up or down. This confusion between what their eyes see and what their body feels results in almost 2/3 of astronauts being ill. This space nausea can last up to 3 days until the astronauts get their space legs. Also within this time period, the cardiovascular system is affected. On Earth, gravity forces blood to pool in the feet. Without gravity's help, blood and fluids pool in the chest, and this causes the heart to swell and pump slower. As more time is spent in space, the body has less need for dense bones and heavy muscles. On Earth, the skeleton is for support, protection, and locomotion. Strong, dense bones are essential to prevent injury. Microgravity reduces the demands placed on the skeleton. As a result, bone density is slowly reduced. The porous structure of the bone becomes thinner as the calcium literally fizzes away. For every month spent in space, up to 2% of bone density can be lost. As a result, bones become brittle, similar to the effects of osteoporosis. Muscle loss also occurs in space. Without the need to constantly overcome the forces of gravity, the demands on the muscles are much lower. To combat bone and muscle loss and prevent any long-term effects on return to Earth, astronauts must exercise every day in specially designed space gymnasiums. Microgravity and its effects on the human body aren't the only obstacles to overcome. Greater and more immediate dangers lurk in space. This is Chad, our test subject. Chad has been volunteered to demonstrate just how dangerous space really is. Space is a vacuum, which means there is no air. And when there is no air, Chad will not be able to breathe. If by some accident Chad is detached from his spacecraft, then he could drift away and never be seen again. If Chad's suit is torn or punctured whilst in space, his career as an astronaut would soon be over. It is incredibly cold in space, around minus 150 degrees Celsius. Without a specially designed suit, Chad would freeze solid in seconds. Space is mostly empty. However, there are some objects out there that Chad needs to look out for. Micrometeoroids are tiny rocks speeding through space. They are too small to be detected and difficult to avoid. Larger meteors are also hurtling through the solar system. However, their size makes them easier to detect and avoid. Almost everything that has ever been launched into space is still out there. There are nearly 4 million individual pieces of space junk orbiting the Earth. As well as heat, the sun emits electromagnetic radiation, just like a microwave oven. On Earth, our atmosphere filters out these harmful rays. Suntan lotion, sunglasses, and a hat are all you need. However, in space, without the protection of a real spacesuit, Chad would quite literally cook. A more sinister type of radiation comes from deep space, in the form of cosmic rays. These cannot be avoided or shielded against, and are capable of mutating or destroying DNA. However, the most dangerous place for an astronaut isn't in space at all, but right here on Earth. More injuries and fatalities have been caused on the launch pad or shortly after blastoff than at any other time. In the beginning of the space age, astronauts spent relatively short periods of time in space. Missions were brief, typically lasting no more than a few days. The construction of space stations means much longer can now be spent living and working in space. But what do astronauts do once they are in space? And how do they cope with day-to-day life in this unique environment? Everyday tasks that we take for granted on Earth become much more difficult. This is how water behaves in space. Imagine trying to take a shower or use the toilet when liquids just float away. A major part of an astronaut's job is to perform scientific experiments and conduct research. Microgravity provides the opportunity to study science in a way that is impossible on Earth. Keeping fit is vital for an astronaut's health. They have to exercise for at least 2.5 hours every day to minimize the long-term effects of being in space. It is essential that regular maintenance and upgrades are performed to preserve the fragile environment of the space station. The smallest problem can very easily become a life-threatening situation. The knowledge we have gained through space exploration in the last few decades alone has had an immense impact on all of our lives. Instant global communication, advanced materials, and computer technology are just some of the tangible byproducts of the space age. Each step further out into space we take alters our perception of what is possible. The exploration of space extends across borders and serves to unite us all in a single common goal of discovery. How different would our lives be today if our ancestors had not embraced such challenges and ventured out into the unknown? Exploration has always been a dangerous and high-risk enterprise. The passion to explore has driven humankind throughout history to discover new frontiers. With this spirit, explorers have always had a relationship with the stars. They have been their constant companions, always present and unreachable. Once they guided sailors across vast oceans in their search for earthbound new worlds. But what will the future hold for the pioneers of tomorrow? Will our desire to constantly reach out into the unknown allow us one day not just to look up at the stars, but to travel amongst them?
Okay, so here is a final view, also VR view from Google Cardboard Camera, and of the inside of the Coca-Cola Space and Science Center. So I'd like to thank you for watching this video. Hope you enjoyed. Have a good one.